Welcome to Formula 1 Maths. This is Mixed Exercise 9.02 GCE A-Level Year 1 Applied Maths. Mixed Exercise 9.02 is on constant acceleration. We're going to answer two questions. Question 1. An aircraft takes off on a straight runway, AB, of length 1.1 kilometers, with initial speed 5 meters per second. The aircraft starts from A, moving with constant acceleration, 4.8 meters per second squared, leaving the runway at C 15 seconds later. Find A, the speed of the aircraft when it leaves the runway. B, the distance BC. The runway can be modeled as follows. So this is the runway, which starts from A and ends at B over here. The runway is 1.1 kilometers, and 1.1 kilometers is equal to 1100 meters. So we get a full length. The plane takes off at A and leaves the runway somewhere here as follows. So we can put C somewhere here. We know that U is 5 meters per second, T is 15 seconds, and acceleration is 4.8 meters per second squared. So we're going to use one of the equations for Suva to find the velocity at C. So we are going to use equation 1, and so if we write it down, we are going to get the following. And all we need to do now is do our substitution as follows. V is equals to 5 plus 4.8 times 15. And then simplifying gives you V is equals to 5 plus 72. And then solving gives you V equals to 77 meters per second. And that's A. For B, we can use one of two equations. We can either use equation number 3, S equals to UT plus half AT squared, or equation 4, V squared is equals to U squared plus 2AS. We are going to use the two equations. First, V squared is equals to U squared plus 2AS. We have got a V, which we calculated over here. We've got U, which we've got over here. And we've got acceleration, which we've got over here. So we just simply do our substitution as follows. 77 squared is equal to 5 squared plus 2 times 4.8 times S. Simplify to get 77 squared minus 5 squared is equal to 9.6 S. Rearrange to get the following. And finally solving gives you S is equal to 615 meters. But we want the distance BC. BC will be from this point here to this point. We have calculated A to C. So all we do now is take 615 from 1,100 meters to get the required length. And so the required length of BC is 485 meters. Alternatively, like I mentioned earlier, we can use S equals UT plus half AT squared, where U is 5 meters per second, T is 15 seconds, and A is 4.8 meters per second squared. Again, we do our substitution to get a following, simplify, and finally solving to get 615. And as we did before, we need to take this away from 1,100 meters, and we get BC to be 485 as before. Question 2. Two particles, P and Q, are moving on parallel horizontal tracks in the same direction. At point X, P, which is moving with speed 60 meters per second and decelerating uniformly at 6 meters per second squared, passes Q, which is moving with speed 8 meters per second and decelerating uniformly at 2 meters per second squared. Find A, the distance of q from x when the velocities of p and q are equal. B, the velocity of p when q overtakes p. So we start by noting the information given for each particle. So for particle p, the initial velocity, up, is 60 meters per second. The acceleration is minus 6 meters per second squared because it is decelerating. We will let the velocity at time t for p be represented by Vp, and the distance at any time t moved by p be represented by Sp. We do the same thing for particle q, and we get the following. Uq for initial velocity, Aq for acceleration, and Vq for the velocity at any time t, and the distance at any time t will be Sq. Since we are looking for the distance when the velocities are equal, we need to find the velocities of particle q and particle p. We're going to use equation 1 to find their respective velocities. So for Vp, we're going to get Up plus Apt. This means Vp will be equal to 16 minus 6t. Similarly, Vq will be given by 8 plus 2t. Now we know that these velocities are equal, so we can equate them and solve for t to get the time when the particles have the same speed. So when the velocities are equal, Vp equals to Vq, so we equate this to this as follows. And then we solve for t, and we are going to get t is equals to 1. That means that at time t equals to 1, the two particles have the same velocities. But we want the distance of q. So we are going to find the distance of q when t is equals to 1. So when t is equals to 1, the distance moved by q will be given by the following equation. Doing our substitution will give us Sq is equals to 8 times 1 plus half times 2 times 1 squared. And that gives 9 meters. And this is the distance moved by q when its velocity is the same as the velocity of p. For b, we are looking for the velocity of p when q overtakes p. So when q overtakes p, Sq will be equal to Sp. So we're going to find the distance moved by each particle in terms of t as follows. So using equation 3, we can find the distance moved by each particle at any time t. For q, we have the following. At plus half times 2 times t squared. That will simplify to 8t plus t squared. Similarly, the distance moved by p in any time t is given by the following equation. This will simplify to 16t minus 3t squared. But when q overtakes p, the two distances are equal. So we equate them to get the following equation. Rearrange to get a quadratic equation in t, simplify to get this, and then we solve to get t is equals to either 0 or t is equals to 2 seconds. But we know that the valid answer here will be t equals to 2. So q overtakes p when t is equals to 2 seconds. But we are looking for the velocity of p when q overtakes p. So we are going to find Vp, which will then be given by 16 minus 6 times 2, because V is equals to U plus AT. And we know U is 16 and A is 6. Simplifying this, we give Vp is equals to 6 minus 12, and that means the velocity we are looking for is 4 meters per second. And this is the end of mixed exercise 9.02. Thank you for watching. I'll see you in the next video.